So good evening, everyone. I will try to be brief and, let's say, present the actual situation regarding the energy consumption and the major problems of the built environment in Europe, and offer some very special, let's say, information that has to do with the main characteristics, the parameters, especially parameters that have to do with the air conditioning and the cooling issues in Europe. In my opinion, three are the major, let's say, problems that we are facing in the built environment actually in Europe. The high energy consumption, the local climatic change, and energy poverty. And I will try to explain why. First of all, as it concerns the energy consumption of the building sector, the actual, let's say, consumption of buildings in the European Union is around to 9 petawatt hours, and this is almost 41% of the total consumption in Europe. And about 27% of the total consumption out of the 41%, it is spent by residential buildings, while the rest, the 14%, is consumed by the tertiary sector. It is very clear that there are major differences between the different countries as, let's say, a result of the different climatic conditions, but also the different economic and social characteristics. For example, the average building energy consumption in Finland is something close to 320 kilowatt hours per square meter per year, while, for example, in Bulgaria is close to 150 kilowatt hours per square meter per year. And, of course, there are big differences between the residential and tertiary buildings. As it concerns the evolution, let's say, of the energy consumption in Europe, the tertiary sector is unfortunately presenting a continuous increase of the consumption during, let's say, the last 30 years. The increase rate is of the order of magnitude of 1%, 1.1% per year. And this is mainly because of the very rapid increase and evolution of the services sector, let's say, in the tertiary buildings, and especially this evolution of, let's say, the services sector is of the order of magnitude 1.5, 1.3% per year. And it is, let's say, calculated that about 93% of the additional energy to be consumed in the tertiary buildings is because, let's say, of the services sector. And space heating seems to be, let's say, the more important of the energy consumption components, but we have to accept that the energy consumption for space heating is decreasing during the very last years. As it concerns the residential sector, and despite, let's say, the very important legislative framework that has been developed during the very last years, and the significant improvement of the energy efficiency, which is of the order of magnitude of 1.4% per year, unfortunately, the energy consumption of the residential sector in Europe has increased by 14% between 1990 and 2012. And this is because 60% of the increase is due to the increase of the electricity consumption because of the additional use of air conditioning, cooling, electronic appliance and devices. And also we have to consider, and it is very important, that the increase of the energy consumption in the residential sector is not only a technical problem, but is very strongly, let's say, interrelated with other economic, social, political, and technical reasons, which really are very much associated with the final energy consumption. I will go through that and explain you. On the other hand, although the energy consumption, for the residential buildings and the tertiary buildings has been unfortunately increased during the very last years, we have a very specific, let's say, decrease of the heating energy consumption of about 15% during the period 1997 to 2009. And this is because, let's say, we have a very significant, let's say, legislative framework, but also we have new technologies that helps to decrease the energy consumption for heating purposes, and also new dwellings really present much lower energy consumption, let's say, that in the previous year. And in most of the countries where heating is the major energy consumption component, the energy consumption for heating purposes has been decreased, let's say, by 50 or 60%. So we might say that we are very successful as it concerns, let's say, the heating energy consumption. Also, we know very well in Europe that space heating is the most energy-consuming, let's say, component for the building sector, representing almost 71% of the total consumption. And while the second one, let's say, is water heating, 12%, cooking 4%, while unfortunately, actually, the data we have combines lighting, air conditioning, and other appliances together, so we don't have specific information about the energy consumption of air conditioning, or we can calculate it. And altogether, lighting, air conditioning, and appliances represent almost 15%. Although this 15% may be considered as low, in reality, the energy consumption for cooling is increasing very, very rapidly. Especially in the countries, in the southern European countries, this energy consumption for cooling purposes is considerably high, and especially, for example, in Cyprus, it is something close to 670 kilowatt hours per year, while Malta is close to 540 kilowatt hours per year. And although we have, let's say, very important increasing rates in most of the southern European countries, similar, let's say, results are also given from the northern European countries, where there is also a very rapid penetration of the air conditioning. In specific countries, this increase of the energy consumption for air conditioning is very significant. For example, between 2005 to 2010, the energy consumption for cooling has increased about 100% in Bulgaria and 30% in Spain and Italy. So it's a very dynamic, let's say, part of the total energy consumption, let's say, conditions actually in Europe. But on the other hand, we have always to consider that the energy consumption of the building sector everywhere in the world is not just a technical problem. It's not just related to the, let's say, technology applied. It is very much related to, let's say, environmental, social, and economic factors. For example, between 2007 and 2012, in the European Union, we had a decrease of 4% of the energy consumption, not because we have applied, let's say, or implemented very efficient energy technologies, but because of the economic crisis. Or in other countries, for example, like in Portugal and in Slovakia and Ireland, the corresponding decrease was of the order of magnitude of 16 to 22%, let's say, which is extremely high. Or just to consider that in the last 3 years, the energy consumption, let's say, for the residential sector in Greece is of the order, the reduction of the energy consumption is of the order of magnitude of close to 70% because, of course, of the energy crisis. So when we're discussing about, let's say, absolute data about the energy consumption, we have always to consider that these data are very much influenced by, let's say, economic, environmental, and social factors. And especially cooling is very much affected, let's say, by the economic and the social conditions. As I mentioned before, there is a significant increase of the cooling energy consumption in Europe, and it is expected that the consumption will continue to increase in the future. And we have to investigate why this happens. And there are several reasons that really can be attributed to this increase. And the very first one, it has to do with the improvement of the living standards in Europe. So people can afford really to buy an air conditioner to face, let's say, problems of overheating. Second, unfortunately, in many countries, actually the quality of the building stock is not the proper one, and this creates important overheating problems during, let's say, the summer period, and people has to rely, let's say, on an air conditioning to achieve the proper comfort conditions. On the other hand, we have to accept that in our cities, and especially in our countries, but most in our cities, global and local climatic change has increased temperatures, has increased, let's say, heat waves, and this, let's say, has imposed or has obliged, let's say, citizens to let's say, to rely to air conditioning. On the other hand, the very important increase of the so-called internal gains, especially the electric and the electronic appliances, also has increased the need for air conditioning, especially in the tertiary buildings. And on the other hand, also we have to accept that people is not aware about, let's say, the alternative technologies for cooling, and so they have to rely immediately to the very simple solution of an air conditioning. While also it is very important to consider that in Europe, the peak load electricity consumption or the peak load electricity prices are quite low against what is happening really in Japan or in the States. So these are the main reasons that really can explain why we are facing an important increase of the cooling energy consumption. And I will try to go through the most important of these reasons, and especially I would like really to present the actual situation regarding, let's say, local climatic change in Europe, which is a more documented phenomenon of climatic change, increase of the temperature in our cities. And it is evident that when temperature increases, the energy consumption for cooling is increasing as well. Well, we have an environmental problem because the concentration of pollutants is increasing as well. Comfort is deteriorated, and also we have important health problems. Is it a serious problem or not? I try really to put together all the existing, let's say, data about the local climatic change in European cities. And you may see, for example, that the absolute maximum intensity of the local climatic change is of the order of magnitude of 6 degrees, the average. And in some places, let's say, the temperature increase, the absolute maximum temperature increase is much higher, where the average annual temperature increase of the order of magnitude of 3 degrees. This is the more documented phenomenon of climatic change, and for sure this has a very important, let's say, impact on the energy consumption. Recently, there is a lot of information published trying to assess, let's say, the energy penalty or the cooling penalty because of the climatic change. And actually, we have seen that the peak electricity demand for electricity is increasing of the order of magnitude of between 0.4% to 4.6% per degree, let's say, of temperature increase. And in average, the penalty of peak electricity demand for cooling is about 20 watts per person and degree of temperature increase, which is a huge, let's say, increase of the energy consumption because of the climatic change. On the other hand, very recent publications have shown that the cool energy consumption, let's say, in the center of the cities all around Europe, is increasing by about 13% as an average. In some cases, we may have a much higher energy consumption, energy penalty, cooling penalty maybe, because, let's say, of the temperature increase. So other, let's say, studies have shown that the global energy penalty per unit of city surface and per degree of local climatic change, it is of the order of magnitude of about 0.8 kilowatt-hours per square meter and degree of temperature increase, which is a very high, let's say, magnitude, while the penalty per person, the cooling penalty per person, it is of the order of magnitude of 68 kilowatt-hours per person and degree. So actually, one of the major reasons that increases the energy consumption for cooling in our countries, it has to do with the local climatic change. And of course, when really we rely and we examine the future climatic scenarios, it is evident that if, let's say, not proper actions are taken in order to reduce global climatic change, we expect, according to the IPCC, that the energy consumption for cooling will be increased by the order of magnitude of 800 or 1,000% during the next 50 to 100 years. And we expect, of course, and we wish not to have such a scenario. On the other hand, it has to be very clear that cooling is very much associated with health problems. And according to a very recent European study that was, let's say, carried out in about 30 different cities all around, let's say, the continent, it has shown that the degree of mortality or the mortality rate in the southern European countries is increasing almost exponentially above 30 degrees. You see, let's say, the line for the southern Europe, while for northern European countries, the increase of mortality is increasing, let's say, at temperatures above 23 degrees. And this is very important, and this has a tremendous cost, let's say, in the health systems of our countries. A very recent study by the British, let's say, health system has shown that for every, let's say, euro invested in energy retrofitting for cooling purposes, almost 40% of this investment returns back because of the health benefits. The third problem we are facing, and it's very much associated with overheating of, let's say, of our buildings and also of cooling, it has to do with the so-called energy poverty, which is a very important threat for Europe. Many people that they never work on this, or they are not aware of the real problem in Europe. They don't know that officially in Europe we have 150 million Europeans which are not able to pay bills and maintain comfortable standards. This is the official number, which means that 150 million people cannot really face the problem of energy during the winter, or mainly during the summer period in the south. And this has a tremendous impact on the quality of life of the citizen and affects indoor comfort conditions, social entertainment, health, etc. And it is very clear that the monitoring of the indoor comfort conditions during the summer period, during heat waves in different countries of Europe, especially for energy poor people, it has shown that indoor temperature may be, let's say, more than 35 average indoor temperature, maybe 35, 36 degrees or even more, and we may have spells of more than 400 continuous hours with temperature above 32, 33 degrees. If you remember what I saw before about, let's say, increased mortality, you can really associate the meaning of, let's say, overheating of buildings with the health problems. So it is very well recognized, and everyone accepts that there is a very important need to reduce the energy consumption of the building sector. And how this can be done? This can be done, of course, through deep retrofitting of the building stock, and of course combined with a very radical reduction of the needs of the new buildings. And it's very important really to understand what has to be done in order to achieve that. It is not an easy task. If we really like to minimize the energy consumption of the building sector by 2050, as it is actually, let's say, the target of the European Union, and according to the official studies carried out in Europe, and there are many studies carried out in Europe, the cost that we have to pay in order really to minimize the energy consumption of the building sector in Europe by 2050, it is something close between 12 to 46 trillion of euros to be invested until 2050. And the cost per petawatt hour, it is of the order of magnitude of 2 trillion United States dollars per petawatt hour. What is more important, and this has to be very well understood, is that the cost of energy conservation is not the same. And it has almost an exponential, let's say, figure and shape. And for, let's say, some of the technologies, the cost per petawatt hour is quite low, and these are the mature technologies, while if we like really to decrease the energy consumption up to, let's say, 70 or 75%, as, let's say, foreseen by the European Union, then the cost of the technologies to be involved as at the upper, let's say, part of the curve, and the cost of this technology is extremely high. So we have really to understand that actually the cooling technologies are in the lower part of this curve, and this is the very, let's say, helpful part of the whole situation. How we can really decrease the energy consumption for cooling in our buildings? Of course, we have to increase the global energy efficiency of the building energy systems. Second, we have, let's say, to substitute a part of the load through clean and renewable energy technologies. But the most important, it has to do with the management of the energy and environmental systems of the buildings through the use of smart and intelligent technologies. Especially the use of smart products in the envelope, for example, natural and hybrid ventilation components, cool coatings, are extremely attractive. And also the use of high-performance heating, ventilation, and air conditioning systems is a huge market, actually. There is a tremendous research. And the order of magnitude of the market, let's say, figure is close to 162 billion euros, let's say, per year, and presents, and this is very important, and growing rate in Europe of the order of magnitude of 10.5%, let's say, per year. On the other hand, if we really like to decrease the impact of global climatic and local climatic change, we have to adopt mitigation technologies. And mitigation technologies are very much associated with, let's say, the use of component technologies for the roofs, component technologies for the city, etc. there's a recent study that has evaluated actually the total investment per person in order to minimize the local climatic change in Europe in order really to avoid the temperature increase. And as you can see, for the different cities of Europe, the investment, let's say, that has to be spent, the maximum investment to avoid the problem is no more than 4,000, this is the absolute maximum, 4,000 euros per person, while the average, let's say, cost is of the order of magnitude of about 1,000 euros per person. So by investing 1,000 euros per person in our cities, we can really mitigate the problem of local climatic change and avoid the problem of overheating. On the other hand, as I mentioned before, in order really to offer additional comfort in the 150 million energy poor in Europe and avoid the problem of increased mortality and also avoid the problem of deteriorated comfort, recent studies have really calculated the cost that has to be paid in Europe in order really to retrofit all buildings of energy poor. And you may see that the absolute maximum of the cost that has to be paid is no more than, let's say, 2 trillion by 2050, or the average is to about 1 trillion. So this is the cost if we really like to improve the energy efficiency of our buildings. I like to conclude by saying that the high energy consumption of the building sector, in combination with the local climatic change, the energy poverty, are really the major problems of the built environment in Europe. All people is knowing very well that cooling is increasing very rapidly, and perhaps in the future, according to all, let's say, foresights and according to all projections, is going to be the major consumption component, let's say. We have to understand, and this is very important, that the problem, let's say, of the energy consumption in the building sector is not just a technical problem, and is not just a problem of technology to be applied in order to decrease the energy consumption. All three sectors, and especially the energy consumption, the local climatic change, and the energy poverty, has to be, let's say, considered in an holistic way. And because they are so much, let's say, interrelated, and there are so many significant synergies and trade-offs, the problem has to be considered completely in an holistic and integrated way. It is true that actually the existing policies in the European Union, and this is understood now, and this is addressed in most of the papers of the European Union, that aims to reduce the energy consumption of the buildings, usually underestimate the importance and the impact of the climatic change, and also the technical, social, and economic implications of energy poverty. During the very last years, the Commission has started really to address the three issues together. But if we continue really not to consider all issues in an integrated and in an holistic way, this will result in higher energy consumption for cooling and for social discrepancies. So it is very important that the problem of overheating and cooling be considered in the frame of, let's say, a more wide, let's say, social agenda. It is possible, actually, to innovate to zero the built environment in Europe, decrease the energy consumption up to a minimum, eradicate the energy poverty, mitigate the urban climatic change, and let's say, improve the living conditions of the European. I have to tell you that I strongly believe that such an objective that really reduces the energy consumption up to a minimum, let's say 1 petawatt-hours instead of 9 petawatt-hours, although it seems that it is a very ambitious target, it is a very, let's say, unequivocal choice that will create substantial really opportunities for growth in the future, and will improve, let's say, the conditions of living of the, let's say, of the European population, and will offer a lot of benefits and opportunities for the Europeans. I'd like to stop here, and thank you very much.